Okay, this is lesson 2-3, and it's rate of change and slope. So pause the video, take a minute to write that down in your notes, and then we will go on. So here's some vocabulary. Again, pause the video if you need to write it down. It is not on the handout. But pause the video whenever you need to write stuff down. I expect this to be in your notebook, and I will check your notebooks for notes. So rate of change is a ratio that compares how much one quantity changes on average relative to the change in another quantity. So we're looking at how one thing changes as another thing changes. So for example, as time goes on, what happens to the population in the US, stuff like that, on average. So this means that we could have a graph that's not constant, so it could go like this, which is usually what the population is doing, growing what's called exponentially. So the rate of change from this point to this point is not the same as this point to this point. And if I'm trying to find a rate of change from like here to here, it's going to be like I'm finding the slope of the line between those 2 points. So it's not that throughout these years, whatever they may be, that it's the same rate, but it's the average rate from that point to that point, just average. So basically that's just change in y over change in x. So your dependent variable, the change in that over the change in your independent variable. Because our independent variable is like our time or hours, which is time. So we want to know population per time, whatever unit you want to be in. If you want to be in years and 10 years, increments, whatever. So that's why our independent variable is always on the bottom. So another way we can say this is delta y over delta x. This triangle is a Greek letter, and it's delta, and it means change. So change in y is the same thing as delta y. Change in x is the same thing as delta x. So if you ever see me write this, I mean change in y over change in x, and I will always say that. So, and it's a quicker way than writing out the words. So that's how you find rate of change. So there are rates, just like I was talking about this nonlinear graph, there are rates of change on nonlinear graphs. It's just not a constant rate of change. But if it is constant, then you have a linear graph. So if your rate of change is constant, then your graph is linear. If your graph is linear, then you have a constant rate of change. Again, pause the video if you need to finish writing notes here. Okay, so for our first example, we're talking about college admissions. So in 2004, 56,878 students applied to UCLA, and in 2006, 60,291 students applied. Find the rate of change in the number of students applying for admission from 2004 to 2006. And be sure to figure out which one is independent variable. So remember, I said most of the time is always going to be your independent variable. So I know that 2004 and 2006 are my x values. So I'm saying from 2004 to 2006, how much time had passed. So this is delta x. I'm doing the denominator here first. So that would be 2 years. Okay, and then how did the y's change? How did the number of students who applied change? So you just need to do 60,291 minus 56,878, which is 3,413, and that's students. So when we talk about rate of change, in a real world situation, we do care about the labels. So your rate of change would be 3, and we want to reduce this because we want to know per 1 year, not per 2 years. You could say 3,413 students over the course of 2 years. Or what's more helpful is we want to know, remember, rate of change is average. So on average, how many per 1 year? So we actually want to divide that out. So if you divide that by 2, you're going to get a fraction. It's 1,706 and a half. We can just round it. So we are going to say, I don't have an eraser on this thing, so it would be 1,707, about 1,707 students per year. And we want to say it increases because it got bigger, the number of students who applied. So the rate of change increases about 1,707 students per year. So remember, this is average, so that does not mean in 2005 that we had whatever 56,878 plus 1,707 is. That's not necessarily true. It's on average from the 2 years. So about 1,707 students per year, an increase of that. Now let's go on to our next example. Okay, for our second example, business, and you should be writing these down in your notebook. I will be checking them. So refer to the graph below, which shows the data on the fastest growing restaurant chain in the U.S. during the time period of the graph. Find the rate of change of the number of stores from 2001 to 2006. So again, we can see this is not linear. So from 2001, which is here, to 2006, it's just going to be an average rate of change. So once we find it, it probably won't work for like year 2003 to add whatever the rate of change is twice to be to 2003, because it's just an average. So let's go ahead and find this. So our independent variable is year again, so how many years have passed? And that is 5. So over 5 years, what happened to the number of stores? Look at your labels. This is not 5 stores, it is 5,000. This is in thousands. So make sure you read your graph correctly. So in 2001, there were 5,000, and then in 2006, there were about, I would say 34,000. So we got to find that change. So we can just do 34 minus 5 and know it's in thousands too. So it's 29. So there's an increase of 29,000 stores. So you need labels again. So 29,000 stores over 5 years. But that's not what I want. I want the average. So I want you to reduce this so that your denominator is 1. Always so that your denominator is 1. So let's do 29,000 divided by 5, and that's 5,800. So 5,800 stores per 1 year. So let's write our final answer as a sentence this time. So we're going to say from 2001 to 2006, the fastest growing the store in the U.S. increased by about 5,800 stores per year. So I'm going to change it to say restaurant chain. So from 2001 to 2006, fastest growing restaurant chain increased by about 5,800 stores per year. And the reason we specify here is because that's the only set of data we got, so we can't say that this trend continues forever. In fact, it looks like it's growing faster as time goes on. So we just do it from the data that we have. So from 2001 to 2006, 5,800 stores per year. Okay, now we're going to talk about slope, which is closely related to rate of change because it's the exact same thing. So it's a change of y coordinates in to this corresponding change in x coordinates. So same thing, except it's a constant rate of change. Because for slope, we're talking about lines. Lines have slope. If you have a graph like this that's not linear, it has slope at different points, but it does not have an overall slope. So that's why when we're talking slope, we're talking about linear graphs which have a constant slope or constant rate of change. So to find the slope between 2 points, x1, y1, and x2, y2, we use this formula. You have seen this formula before. This is a review of Algebra 1. So our slope, which we call m, is y2 minus y1 over x2 minus x1. So that's your change in y coordinates and your change in x coordinates. Also, you've probably heard rise over run. So how far do you go up or down? And then left or right. So on this, it says the corresponding change in x coordinates. So notice that I started with my second y coordinate on the top, so I have to start with my second x coordinate on the bottom. Corresponding, because they were talking about how far is this point from this point. So you can't mix them up. You can't do y2 minus y1 and then x1 minus x2. Has to be in the same order. So really you could do y1 minus y2 and then x1 minus x2. You could do that. But generally our y2, x2 point is further to the right. So it's like our now and then minus a point that was prior to that point. So it came before that point. So, and it really doesn't matter, but this is the formula. And I'm going to show you another way that I think is a lot easier than the formula anyway. So this is for our points. This is our second point, so we're starting with that first. Also, if x1 is equal to x2, this will not work because the denominator will be 0, and we cannot divide by 0. So if you ever have the x values the same, so I don't really care what's in the numerator, but if the denominator is 0, that means the slope is undefined, which means the line is vertical. Because you'll have something like 1, 2, and then 1, 4. So that means that you have two outputs for one input. So we already know it's not a function. And that means that x equal to 1 has an output of 2 and 4. So that's, if you draw a line between those 2 points, you get a vertical line. And that has no slope because the x value does not change. So the slope is undefined. Now if your y values are equal, so if you have like 2 minus 2, then your numerator would be 0. And again, I don't care what the denominator is as long as it's not 0, because then that would be the same point. But if the numerator is 0, that means the slope is 0. That doesn't have no slope. You can't say it has no slope because it does. The slope is 0. And that would be for a horizontal line. So horizontal lines have a slope of 0. Vertical lines have no slope, which means the slope is undefined because it does not move from left to right. So again, rate of change, slope is rate of change that is constant, and this is the formulas that you have used before to find that slope. So now we're going to do some examples with it. So example 3, find the slope of the line that passes through -1, 4 and 1, -2. Use two different methods. So I want you to use both methods here, and then you can choose which one you like or use them interchangeably. It doesn't matter to me. But I just want you to have an example of both. So let's start out with using the formula. So I'm going to do my slope is y2 minus y1 over x2 minus x1. I'm going to say this is my first point. So this is another reason why it really doesn't matter which one you start with, as long as you start with the same one in both the numerator and denominator, because I could have labeled this one x1, y1. Usually though, your x1, y1 is the one that comes first, so it's furthest left, which is this one, because we have an x value of -1. So my y2 is 4, I'm sorry, it's -2, minus my y1, which is 4. So that's my change in y, over my change in x. So my x2, which is 1, minus my I said x2, right? x2 is 1, minus my x1, which is -1. So be careful here. You're subtracting a negative. And now we just reduce. So subtracting a negative is adding a positive. Back to the numerator, -2 minus 4 is -6, over 1 plus 1, which is 2. And you always need to reduce your slope. So we're going to change that, reduce it to -3/2. Do not write it as a mixed number or a decimal, because the whole point of finding slope is to help us graph a line. That's what we're going to use it for in the future. And when you're graphing a line, you do not want to have it written those ways, and you'll see later, because again, this is rise over run, so it tells us how to get more points more easily than using a decimal, which could be repeating, which is bad news anyway. And also, we don't want a mixed number either. So that was the first method. The second method is to use your delta y over delta x. So your change in y over change in x. So you're doing the same thing, it just is easier. So what I always do is write my points side by side. So -1, 4, and then 1, -2. Doesn't matter what order you put them in. And then you're just going to ask yourself, how does y change? Because that's what this is asking. How does y change from one point to the other? So how do I get from 4 to negative 2? Well, if you're looking at a graph, you would have to go down 6 units, which is the same thing here. I would have to subtract 6. So your change in y is minus 6. And then we're going to do the same thing for x. So how does x change? What is delta x? Change in x. How do I get from negative 1 to 1? You would have to add 2. So it's plus 2. Your change is increasing by 2. And then all we have to do is reduce that. So again, we get negative 3/2. So I like this method a lot better. I think it's quicker. And another thing it avoids for you guys especially is the subtracting a negative. You won't mess that up. A lot of people will just forget to write the subtraction sign and then just write the negative 1. So just 1 and then negative 1. And forget to include that subtraction sign, which will mess up your answer. So doing it this way, I think, is a lot easier. But again, I do not care which method you use. I will continue to do both methods so that you can see how they're both used. All right, the next example, you have a graph this time. So find the slope of the line below. Because graphs of lines have a constant slope, you can choose any 2 points to find the slope. So you just have to pick the points off this graph. However, you need to choose nice points. So I'm not saying I suggest, I'm saying you have to choose nice points. Because really, yeah, you could choose this point right here, but you don't know exactly what that point is. It's like 1.5 maybe, and like maybe 1 1/3, but I can't be sure. So what you need to look for is points where it intersects, where the grids intersect, where these lines intersect. So like here, here, you have to choose those nice points because those are exact. So why don't you choose different points than me? I'm going to choose, and you see if you get the same slope, which you should. So I'm going to choose this point. So that point is -3, -1, and then I'm going to choose this point, which is 3, 2. So I'm going to use the formula first. So y2 is 2, y1 is -1, so it's 2 minus my y1, which is -1. And then in the denominator, my x2, which is 3, minus my x1, which is -3. So we have 2 subtracting negatives going on here. And so when I reduce that, 2 plus 1 is 3, and 3 plus 3 is 6. So my slope for this one is 1/2. And you should get the same thing. Now I'm going to do it my second way. So how do you get from one to the other? So how do you get from -1 to 2? Well, you have to add 3. So that's +3, that's your change in y, over your change in x. So how do you get from -3 to +3? You have to add 6. So change in y over change in x is 3 over 6, which is, again, 1/2. So either way you want to do it is fine. We're going to do one more example with a graph. So again, you need to begin by just pulling points off the graph. So again, try to choose different ones than I do. I'm going to choose ones in the middle this time. Well, there's only 3 points, so you're probably 3 nice points, so you're going to pick one that I do. I'm going to pick this one in the middle. So I'm going to choose -2, 0, and then I'm going to pick this one over here, which is -1, 2, 3, 4, -4, 1, 2, 3. Formula, y2, which is 3, minus y1, which is 0, over x2, -4, minus x1, which is a -2. So I'm adding a negative. Reduce that, 3 minus 0 is 3, and then -4 plus 2 is -2. So my slope is -3/2. Use my other method. How do you get from 0 to 3? You add 3, so your change in y is +3. How do you get from -2 to -4? You have to add subtract 2. So your slope is negative 3 halves. And saying negative 3 over 2 or 3 over negative 2 or negative 3 halves, all the same thing, just as long as you don't have negatives in both. Now, if it ended up there were negatives in both, that's okay. It just would mean the slope is positive. And just like I was doing, how do you get from one point to another? You can go backwards too, as long as you go backwards in both. So how do I get from 3 to 0? Subtract 3. How do you get from negative 4 to negative 2? Add 2. So that would have given you negative 3 over 2, which is the same thing as, like I said, 3 over negative 2. So your slope is negative in this one because we're going down from left to right. The previous one, we were going up from left to right, I think. Yep, so that was a positive slope. Couple more examples. Find the slope of the line that passes through negative 7, 5 and 2, 3. Do your formula one first. Again, you can do either one. You don't have to do both. y2, which is 3, minus y1, which is 5, over x2, which is 2, minus x1, which is negative 7. So we're actually adding here, subtracting a negative. 3 minus 5 is negative 2, and 2 plus 7 is 9. So your slope, negative 2/9. Other method, your change in y, how do you get from 5 to 3? You subtract 2. How do you get from change in x? How do you get from negative 7 to 2? You add 9. So again, your slope is negative 2/9. Last example. I'm going to do the quicker method first. So change in y, how do you get from negative 12 to 6? You add 18 because you add 12 to get to 0 and then add 6 more to get to 6. So that's adding 18. Then how do you get from negative 9 to negative 20? I'm getting more negatives, so I'm subtracting how much? 11. So your slope is negative 18/11. So that's not a very nice slope, but that's okay. At least you're not graphing it. Now I will do the formula way. So m equals y2, which is 6, minus y1, which is negative 12, over x2, which is negative 20, minus x1, which is negative 9. So we're adding a negative here. Adding a negative here. 6 plus 12 is 18. Negative 20 plus 9 is negative 11. So you get the same answer no matter what. So that was your last example. You do have homework. Homework 12 is due on Friday, or due whatever we meet next. And that is 2, 2, and 2, 3. This is on your homework sheet, and it's only 27 problems. So you will have the rest of the class time to work on it.